So here we have a velocity selector. So we have an electric field and a magnetic field. So the magnetic field is given by this, 0.064 Tesla, and the electric field is given by this potential difference between the two plates and this separation of the two plates. For part A, all they want is an expression. So they just want to write the formula for the electric field and the magnetic field. And what we've got is an electron. So the electric field, so if we're going to answer A1, the electric field Fe is, the electric field force, or the force due to the electric field. So the question is slightly confusing because it says the electric field, but what they actually are asking for is the force due to the electric field. So that means Fe. And the force due to the magnetic field. So that's Fb. Okay, maybe we use uppercase E to make it clearer. So we have an electric field force, or electrostatic force, and we have a force due to the magnetic field. So the force due to an electric field, we know from electrostatics, is the electric field times the charge. And the electric field is, or can be written as V over D. So we can write this as V over D times Q. Now V over D, V is your separation of your potential difference, and D is the separation, and Q is the charge on the electron. So we can write it as V over D times E. So that is your electric field. They don't ask for us to calculate anything, just an expression. So this should be enough. For part 2, it's the same, but for the magnetic field. So the force due to a magnetic field is proportional to the magnetic field strength, B, is proportional to the charge, Q, and it's proportional to the velocity, V. So we can say Fb equals B times Q times V. There's probably a sine theta here, but because it's a velocity selector, we know that it's perpendicular and theta equals 90 degrees. So for part B, it says calculate the speed, so that means this V, that would allow the electrons to pass straight through the selector. Now, if you remember how a velocity selector works, you have your electron and it's traveling with a velocity V, and there's two forces acting on it. There's an electric force, or a force due to the electric field, let's call it Fe, in one direction, and in the opposite direction there's another force due to the magnetic field. And these two forces have to be the same for the electron to pass without any deviation. Okay, so this is your electron, and it's traveling in this direction. This force has to equal this force. So this expression has to equal this expression. So we can write V over D times E equals B, and instead of Q, I'm just going to write E, the charge of the electron, V. Now this V is the velocity, whereas this V is the potential difference. So they're not the same. But what I can do is I can divide both sides by E, the charge of the electron, because that is the same. So I can rearrange and say V equals V, uppercase V over BD. And then you substitute the numbers, 2000 over 0.064 times D, which is the separation between the plates, 0.04. So it should be really, really fast. So it's 2000 divided by 0.064 times 0.04. Which is 781 times 10 to the power 3. Meters per second. So that's how you'd find the speed. So in a velocity selector, you always equate these two. So this expression would be equal to this expression. That's how you find your velocity.